The webinar will begin in 1 minute. Good afternoon, everyone. My name is Kurt Epstein, and I'm a senior editor with Aviation International News, covering the FBO, airports, and aviation fuel segments. I'd like to welcome you all to Sustainable Aviation Fuel 101, your SAF questions answered. Thank you for joining us. This webinar is sponsored by World Fuel Services, a leader in sustainability solutions. World Fuel Services has been at the forefront, driving business activity around sustainable aviation fuel. Over the past 4 years, they have delivered nearly 500,000 gallons of SAF to business aviation customers and over 13 million gallons to commercial customers. Along with being an early member of the Coalition for Sustainable Aviation Fuel, World Fuel continues to sponsor further education and awareness to these critical industry objectives. From Van Nuys and Farnborough to today's webinar, they support the sustainability objectives globally in aviation and beyond. If you have your finger at all on the pulse of the industry, you are no doubt aware of the push for environmental improvements in the operation of business aircraft. Last year, a consortium of business organizations released the Business Aviation Guide to the Use of Sustainable Alternative Jet Fuels, which stated that the single largest potential reduction in aviation's greenhouse gas emissions will come about through the broad adoption of sustainable alternative jet fuel in place of the current fossil-based jet fuel. Since then, there was Business Jets Fuel Green, a step towards sustainability this past January at Los Angeles area Van Nuys Airport, which represented the first commercial availability of sustainable jet fuel by the business aviation industry. And Fueling the Future, which involved SAF fueling at airports in the US and Europe ahead of EBACE. Just last week, there was SAF available at Wyoming's Jackson Hole Airport in a similar demonstration. This is a global initiative, and companies around the world are working on ways to develop, distribute, and utilize this renewable fuel, which will only become more important going forward. Joining us today are two experts in the field, Marcelo Gonçalves and Tom Parsons. Marcelo is a product development engineer at Embraer. Since 2008, he has been working in research and technology, working on several alternative fuels projects, which have helped certify new technologies and leverage the alternative fuels production chain, mainly in Brazil and Europe. Tom is the commercial development manager for Biojet at Air BP, overseeing Air BP's sourcing and supply of sustainable aviation fuel. He joined BP as a research chemist, working on the development and scale-up of technologies, including BP's Fischer-Tropsch process. He has since held business development and strategy roles in technology licensing, BP's fuels business, and downstream commercial development. He led BP's advanced bioproducts team from its inception before joining Air BP in 2017. We welcome your questions about this topic. Just type them in the webinar question field and we'll address them during the Q&A session at the end of the webinar. Now, before Marcelo presents, we'd like to start off with a poll question. We'll give you about 60 seconds to answer and then we'll present the results. Is there any reason why you wouldn't run SAF in your aircraft's turbine engines? The choices are now appearing on your screens. All right. The two top results were I don't know if SAF is approved in my aircraft's engines, and I don't know where to find SAF. And those two, it will be answered today, hopefully in this seminar. I'll now pass this off to Marcelo.
Hi, Kurt. Thanks for the introduction. I'm very proud to be here today talking about sustainable aviation fuels. And I hope people listen us to understand that it's very important for aviation. Why is important for aviation? Well, my next slide, please. I have two slides to make an introduction about Embraer. Embraer was born in Brazil 50 years ago and became a global company with industrial facilities in Brazil, United States, in Florida, in Europe, and in Portugal. We have customer support center and commercial offices spread out around the globe. Today, we have almost 20,000 employees working for our company. Next slide, please. This is the most visible face of our company, our products. Commercial aviation, we have more than 100 airlines operating our commercial aircrafts. We are one of the leading company in executive jets with, in fact, with more than 1,300 jets delivered. And we have our defense and security products being operated for more than 60 armed forces. In summary, we have more than 8,000 aircraft delivered and in operation. Well, let's jump into the subject of our webinar today. Next slide, please. Well, aviation climate actions. Let's set the scene for sustainable aviation fuels, or SAFs, as we call. Aviation industry has an ambitious target for emission reduction, reducing 50% of the net CO2 emissions by 2050, compared with the 2005 levels. The industry has made significant progress in reducing its environmental impact. Over 10 billion tons of CO2 were avoided since 1990. It has been possible through a combination of improvements at these four pillars that you have here in our slides. Infrastructure, global market-based measures, technology, and operations. Let me talk about some examples. In operation, air traffic management modernization. It's very important for shortening routes, improving the efficiency of the system, and of course, reducing delays. We are reducing the fuel consumption and we are reducing the CO2 emission. In terms of the infrastructure, airports are using alternative energy for ground equipments, biofuels or electric cars. Global market-based measures. The main example here is the ICAO CORSIA. ICAO is an international civil aviation organization, and this CORSIA is a reduction scheme for CO2. Airlines will start offsetting the growth of CO2 in international flights between voluntary states. But the pillar where OEMs and an OEM like Embraer has the most important contribution is in the technology. And you have two fronts in terms of technology. Aircraft improvements, such as new wing designs, new engines, fly-by-wire solutions to improve the overall aircraft efficiency. This is the case of, for example, our E2 family. And the other front, and a very important front, because we not updated we not launch new families every year, is the sustainable aviation fuels. The example that we have here in the slide is the case of supporting the development of Camelina oil chain in Europe, allowing flights with SAF from Oslo Airport to Amsterdam Airport. These are the four pillars that are supporting the development of industry in terms of sustainability, and we are talk a little bit more about sustainable aviation fuels in this webinar. But first of all, let's understand what the conventional fuel. Next slide, please. Oops. One more, please. Oh, this one. Thank you. Conventional fuel and sustainable aviation fuels. we need to understand this difference. The conventional jet fuel or aviation turbine fuel, that's the technical name used in some standards, is the fuel derived from conventional sources. And according to ASTM International, these conventional sources are crude oil, that's the largest source used, natural gas, liquid condensates, heavy oil, shale oil, mainly in the United States, and oil sands. Alternative aviation fuel is a synthetic fuel. This synthetic fuel is produced from non-conventional sources. We have many conventional sources. I usually classify this non-conventional sources and renewable and non-renewable conventional sources. The most famous non-renewable sources are coal, the oldest used, and natural gas. In the renewable sources, we have many renewable sources, but here I'm listing some of them, like vegetable oils, used in cooking oils, wood residues, or sometimes called lignocellulosic materials, municipal solid waste, industrial waste gases, and microalgae oils more recently. It's important to say that an alternative fuels that are certified for both quality and sustainability will be designated as sustainable aviation fuel. Sustainability certification is a critical point, is a relevant point for the aviation industry. If we only have sustainable aviation fuel, if we are renewable source, be certified as sustainable, okay? It's something very important for us. But before the sustainability, let's understand about an important concept that we have in aviation, that is drop-in constant. Next slide, please. Ensuring safety and performance. Safety is the first concern in terms of aviation. Performance is the second one. Sustainable aviation fuels must be drop-in. A technology candidate that is seeking for approve its technology as alternative aviation fuel must be drop-in and needs to deliver the same level of safety and performance when compared to the conventional jet fuel. Conventional jet fuel is the fossil jet fuel that have been used for decades in aviation turbines. And why we needed this drop-in fuel? Because there are something like 24,000 aircraft in operation around the globe. There is no chance for ongoing modifications at the engines or aircraft fuel systems, even the fuel supply infrastructure. There is no space for change. Please, looking at the slide, in the table 1, in the center of the slide, this table 1 is named Detailed Requirements. This is a partial view of this table. This table appears in the most important ASTM standard for aviation. Is the standard D1655 in the left side of this table, you can see. This is the standard for aviation turbine fuels or the conventional jet fuel. When you look for the right side, in the other white box, you can see the ASTM D7566. This standard has similar designation of the conventional jet fuel, except for the containing synthesized hydrocarbons. This standard is dedicated for drop-in alternative aviation fuels, and it has the same table 1 that is used in the conventional jet fuel. It shows that all alternative aviation fuels, independently of the technology used to produce, must meet the same final specification of the conventional jet fuel to be considered drop-in. In summary, if you have a conventional jet fuel and you have a synthetic jet fuel or alternative aviation turbine fuel, they must meet the same final requirements. And when an alternative aviation fuel meets all the requirements of this standard D7566, it can be redesignated as conventional aviation fuel. It was defined by authorities because both standards deliver the same level of quality. This is something important for those that are not familiar with alternative fuels. The final quality of any alternative fuel must meet the same final quality of the conventional jet fuel. But how we can approve a new technology as an alternative fuel? In the next slide, we can see the process. Next slide, please. This is the process at the STM to approve a new technology in alternative aviation fuels. It's a very summary view of the process. It's a very complex process, and the approval process happens at ASTM Subcommittee Aviation Fuels. That's the main forum to approve any alternative aviation fuels, the new alternative fuels for aviation. Well, the focus of this subcommittee is safety and performance. If a technology candidate able to produce an alternative aviation fuel wants to include your technology in the standard, D7566, you need to follow the process in the slide. The first step is the tier 1. You should go to an ASTM meeting with technical data. For example, the data described in the table 1, mentioned in the slide before, and request to open a task force. After your task force request be accepted, you need to provide a lot of data. Mailing the tier 2. Tier 2 is a step that you have many tests to be done. For example, you need to provide information related to the property behavior, such as density versus temperature, viscosity versus temperature. And another important step at the tier 2 is the material compatibility. Material compatibility test for metallic and non-metallic parts need to be performed. It's a very important step at this tier 2. After that, the preliminary report will be evaluated by OEMs and being approved. The candidate technology go to the tier 3, where fuel system and components and APU, the APU means auxiliary power unit, will be tested. After that, we have the tier 4 engine tests. This tier 3 and 4 takes a lot of time and it's quite expensive. After these tests be run, the report will be updated and will be submitted by OEMs and by FAA to be reviewed. The next step, almost in the final step, it's very important that you be the ASTM ballot and discussion. Being approved in this discussion and in this ballot, the technology candidate will be included in a new annex at ASTM D7566. This process takes a long time. It's not a fast process. Usually take 2 years, 3 years. In some cases, took 4 years. But the most important for those that are not familiar with sustainable aviation fuels, that this process is very robust. The balloting process provides a strong interaction among the ASTM members, and at the ASTM you have oil companies, technology companies, OEMs, engine OEMs, aircraft OEMs, system OEMs that have opportunity to discuss and to request more data if necessary for the technology candidate representatives that seeking approval at the ASTM. Everything is done considering the safety and performance of the aircraft. We need to deliver the same level of performance in the final when you are developing a new alternative aviation fuel. But what are the technologies that you have approved at the ASTM? In the next slide, you have opportunity to see the 5 technologies approved. Well, in this chart, we have these 5 blue boxes, and they show the technology that we have approved. You can find, when you open, for example, this standard, is interesting because in each annex, you can find the technology requirements for the neat product, the product that will be blended with conventional jet fuel in the maximum blending approved. Looking at the box, the number in parentheses represents the maximum blending for the neat product. The reasons for the blend limits are to ensure the appropriate level of safety and compatibility with aircraft fuel system. Made into the level of aromatics. Aromatics is a chemical component that's very important. There is a minimum of aromatics in terms of sustainable aviation fuel composition. And this minimum of aromatics is necessary for different systems, meaning for fuel system, and meaning to allow the performance of some elastomers. Every time that a new process is certified, this standard is amended, incorporate a new annex. The next annex will be Annex A6. Well, let's talk about the annex, this 5 annex that you have. Annex A1 and Annex A4, if you see, they have almost the same name, exactly for the /A in the Annex A4. They are based in the same process. The process is called Fischer-Tropsch, and this process converts carbon monoxide and hydrogen in hydrocarbons in alternative aviation fuel in a product similar to the conventional jet fuel. In this process, coal and natural gas are the non-renewable sources used, and municipal solid waste and wood biomass are the renewable sources most used. The difference between A1 and A4 is that the A4 has aromatic stream added. As I commented before, the presence of this chemical component aromatic is important for the performance of some systems. Look for the Annex A2. Annex A2 is the HEFA, hydroprocessed ester fatty acids. This annex was approved in 2011 and was the first one fully dedicated to work with renewables feedstock. The HEFA can be produced from a large variety of feedstocks, such as vegetable oils, used cooking oil, animal fats, and microalgae oils. Together with Annex A5, these two annexes are the best selling in terms of sustainable aviation fuels. In the Annex A3, we have the synthesized isoparaffins from fermented sugars. The reason for such a low percentage, if you can see, it's the only one that have the maximum blending of 10% instead of the others that is 50%, is due to the fact that they use only a single molecule. It's not a set of chemical molecules, different from example that you have in the other annex. They use only a single molecule. That's the reason for such a low blend. And the main feedstock in this case here is sugar cane. Our last annex, an Annex A5, alcohol to jet. We have performed some flights with alcohol to jet this year. You can see a picture here with a Predator 600, and alcohol to jet is really derived from ethanol or isobutanol. Isobutanol is an alcohol with 4 carbons. Ethanol has 2 carbons. These alcohols can be made from wood biomasses or biomasses used from sugar, or more recently a technology that uses waste gases to produce ethanol. The approval process of the standard, the ASTM D7566, is very dynamic. Today, there are other 6 technologies in the ASTM pipeline seeking for approval. Probably we have a new approval this year, and other 3 or 4 for 2020. But the good point of these technologies that are work with many different feedstocks, which can collaborate for identify pathways with lower CO2 emission. Well, moving to my last slide, the next slide, please. Well, this is my final remarks. SAF is growing day after day. It's growing slow, but it's growing. Look at the map. I hope that you can see the yellow airplanes flying. This map is can be found in the link below, in the source here in planfinder.net. And it was a screenshot that had been made 2 weeks ago. And this screenshot shows the flights that are flying only in using, SAF. We have more than 200,000 commercial flights since 2011. You can think, oh, it's just we have this flight every day around the world. It's a small number. Okay, it's a small number, but have in mind that SAF is a new chain. It's under development. Mainly compared with other biofuel industry, you have a small number of plants producing SAF around the globe. But in our opinion, there is no chance for return. SAF is very important because aviation is liquid dependent. Electrification, mainly for commercial craft, is still for the aviation industry is aware about its responsibility with the environmental and truly committed to reduce the global emissions. For this reason, we rely on sustainable alternative fuels as part of the solution. There is no way to return. We need to have sustainable alternative fuels for this huge amount of aircrafts that will be flying for many, many years. Thank you very much, and I'm very proud to be part of this webinar. Thank you.
Thank you very much, Marcel. Once again, please remember to enter your questions onto the website. We'll handle them at the end of the presentation. Now I'll hand it off to Air BP's Tom Parsons.
Hopefully everyone can hear me. I was sorry, I went back onto mute for some reason there. Really great to be here, and I'm excited to tell you a bit more about sustainable aviation fuel. Great. Next slide, please. I just wanted to kick off just sharing a bit of context from the wider BP group. Air BP is part of the broader BP group. At BP, we talk a lot about the dual energy challenge, and what we mean by that is within the context of increasing population and a real growth in global middle class, prosperity and people being lifted out of low incomes. That's resulting in a really huge growth in primary energy demand. So you can see a stat on the slide there, 33% increase by 2040. That at the same time as global consensus of really needing to transition to lower carbon forms of energy and reducing absolute carbon emissions. That at a global level is clear. And I think in aviation, we have an even starker challenge where the demand is actually going up by even more than 33%, right? In that same kind of time frame, we're talking about a global aviation industry doubling in size. At the same time, with a real need to respond to climate change and reducing the emissions of the sector. I'll go on to the next slide, if I may, please, and I'll talk a little bit more about what Air BP is doing, because this is a microcosm of the bigger picture. So Air BP is the aviation fuel marketing business of BP, and we've been active. I mean, we're sort of more than 90 years old now, but in specifically around low carbon. We've been involved in some of the very early test flights here in 2008, 2010, 11, but we really got started in 2015, 16 here with sort of a number of activities across the low carbon space. So that started with us being the first fuel supplier to be certified as a carbon neutral operator. So we, at all of the sites globally where we operate, we have a 10-year carbon reduction plan, and under the PAS 2060 program are certified carbon neutral. So we've identified what the carbon footprint is, put in place a plan to reduce our footprint over time, and then any residual emissions we carbon offset in order to create a net neutral position. So that's us looking after our own footprint. And then we look at what we can do to help our customers with their own carbon challenges with their own response to the emissions of their operations. So we make available sustainable aviation fuel to our customers under our BP Biojet brand. And I'll tell you a little bit more about what we're doing there specifically later. And we also work with another part of BP called BP Target Neutral, which is actually a not-for-profit part of BP that invests in carbon offsetting projects all over the world, creating both very high quality voluntary carbon offsets, but also local socioeconomic benefits. And we make those available to our customers, as well as obviously using those for our own operations to make those carbon neutral. Great, next slide, please. So at this point, I sort of want to pause and just try and tackle the question of why are we interested in sustainable aviation fuel, building on some of Marcello's comments, and then why is sustainable aviation fuel of interest when we're reducing our carbon footprint. So it's clear in aviation that we are not going to be able to make a material move into electric aviation for several decades to come, and probably longer when we think about wide body long haul operations. Therefore, we're going to need to work with the infrastructure that we have, and therefore we need to reduce the carbon footprint of the fuels that we use. The biggest contributor to the carbon footprint of the fuels is what they are produced from. So if you're using a carbon that has been extracted from the ground, then you're adding to the overall amount of carbon in the atmosphere. So instead, what we want to try and do is reuse the carbon that's already in the atmosphere. So that would be either from crops, from wastes, or by actually pulling out CO2 from the atmosphere and using that directly. So the three kind of boxes you can see on the slide talk about the kind of typical types of feedstock that we can use to convert into sustainable aviation fuel, and some of the pros and cons of those. So first of all, there's the kind of conventional feedstocks that are agricultural feedstocks. So they might be grains like corn, they might be oil crops like soy, or they may be sugar crops like sugarcane. The greenhouse gas savings of these vary, and there are some risks associated with these. If not managed in a sustainable way, there can be the risk of displacing food production and causing deforestation inadvertently. So there are strong protocols in place now to try and prevent that. However, this is a big contributor to the reason why palm oil is seen as a not very sustainable feedstock. That's because it's associated with deforestation, destruction of habitats in certain parts of the world. So that being said, where these feedstocks are managed carefully, you can get reasonable greenhouse gas savings of up to perhaps 70%. That's a particular example you might find for sugarcane in Brazil. But if we could use wastes that are already available and would otherwise be being disposed of in landfill or through incineration, then that's got to be a really good option. And that's what we see in this middle column here. So examples of waste that we can use to convert into SAF are used cooking oil, animal fats, which we call tallow, other waste greases, also things like municipal solid waste, so our household garbage, the trash that's otherwise thrown out after we've recycled those things that can be recycled. There's a lot of energy still left in those wastes that can be recovered and turned into fuel. Other things like waste wood, the leftovers after agricultural production like straw, corn cobs, and so forth, and the food waste that we otherwise throw away. And also on the gaseous side, the gas side, we can also make use of the gas that comes off the top of landfills, for example. That's just methane, like natural gas, and that can be converted into fuels. Also waste carbon monoxide that might come off steel production. So there's a lot of great technology and technological innovation here that have led to some really interesting new processes here. And the benefit of that is you can get between 60 and even 100% greenhouse gas reduction over the life cycle of the use of that fuel. So these are great from a carbon reduction perspective and can also solve some other issues like trying to dispose of waste and do that in a sustainable way. However, by their definition, these are wastes, so we can't just scale those up as we want to make more and more sustainable fuel. So that leads you to say, well, how are we really going to get to the kind of levels of sustainable aviation fuel that we need to reach the long-term decarbonisation goals of this industry? And just to give you a sense of what the ambition is here, so the industry, this is a sort of an IATA and an ATAG goal, is to have a 50% reduction in the overall industry's CO2 emissions by 2050 compared to 2005. And that's obviously in the context of more than doubling, as I've said, the size of the industry. So we're talking about a 75% or more reduction in the carbon intensity of the industry. If we're to actually achieve that, estimates vary as to how much sustainable aviation fuel you need, but it could be as much as 30 or 40% of the global jet fuel supply to get to that level. That could mean something in the region of 150 million tons of sustainable fuel. We can't do that from wastes, clearly. There's risks if we do it from conventional land-based in terms of having a more negative impact on the environment than we even began with. So we need to look at other options. And there's a number of really interesting things being looked at here. They would include new types of oil crops that actually improve the soil while they're growing, or can grow in the winter season as cover crops, so they actually protect the soil for the food that grows in the summer. Other things like energy cane, these energy crops that can grow in marginal land that's not suitable for other uses. And another angle that's getting a lot of interest at the moment is what's called power to liquids, or power fuels, or electrofuels. These are all words that mean the same thing, and that's effectively taking renewable power, so from wind or solar or hydro power or any other source that's renewable, using that to produce hydrogen from water, so doing electrolysis and splitting water to produce hydrogen, and then combining that hydrogen with CO2 that could either be directly pulled out of the air or could be captured from industrial emissions elsewhere. These are great, all of these options, because they are scalable. So that gives you the same opportunity in terms of greenhouse gas savings, so 60 to 100%, with a much lower risk of unintended environmental consequences. The downside here is that we're still discovering the technology as an industry. It's going to take time to scale that up, and as of today, these are by and large more expensive than the other alternatives in the waste feedstock space. However, something that we need to keep an eye on and is going to be really important going forward. So if we move on. Marcello's already talked about a lot of these, so all I'm going to focus on is just a quick recap and mentioning who the leaders are in terms of technologies in this space, because that sets the scene for some further comments to come. The HEFA process is the production route that's the only one currently producing commercial volumes of SAF, and those are produced by Neste and by a company called World Energy in California. And the World Energy plant uses the UOP technology. Neste have their own technology. Alcohol to jet is increasingly coming into play. So Gevo are in the process of scaling up towards commercialization, working with butanol derived from corn, and LanzaTech are working with waste industrial gases through an ethanol to jet fuel process. And then I think the other key pathway to just focus on is the Fischer-Tropsch FT SPK, working with municipal solid waste. So there's a number of plants in development there. One company called Fulcrum that actually, as BP, we have a part ownership stake in. We invested in them back in 2016. And other projects as well are coming forward that will convert household waste into jet fuel via the Fischer-Tropsch process. Okay, let's jump ahead again. And I'm just think it's worth re-emphasizing here how the so the fuel that we produce is absolutely chemically indistinguishable from the regular jet fuel component, and it goes through that recertification process once it's blended, and then from that point forward, the fuel can be used through all of the existing infrastructure. There's no modification needed for any of those systems, or most importantly, to the people on the line, to any of the aircraft that are in operation today. So any aircraft that's certified to the latest standards of the fuel specifications, whether that's ASTM D1655 or Defence Standard 91091, this fuel is suitable for use in those engines. Great, next slide. I'm gonna put this slide in mostly for you to refer back to for when the slides are shared, to touch on some of the things that are actually constraining the blend level here. It's really around density and viscosity. Otherwise, we would be able to blend at a higher level. From a kind of quality perspective, this is very high quality, pure hydrocarbon fuel, and it's just a question of managing the properties that we need to have in the engines the way that they work today. I know that there are OEMs today working on moving to even higher blend levels and ensuring that the equipment that they're producing is able to handle higher blends, whether that be 80% or even 100%. There are some test flights going on at 100% with HEFA to show that that's possible. Okay, next slide. One other side benefit that we can derive from the sustainable aviation fuels, because of their very high quality, is actually, so there is no sulfur contained in the sustainable aviation fuel, because that's not so prevalent in their feedstocks as sulfur is in crude oil. So that can have an air quality benefit, and because of the lower aromatic content, we can see an improvement in air quality from reduced particulate emissions as well. So there's these sort of side benefits that we can also achieve. Research is still ongoing into those, and there has been a NASA study that suggested that there can be quite a significant improvement in the or sort of reduction in some of the negative impacts that you see at altitude in terms of contrails and so forth. That research, as I say, is still ongoing, and I think we'll learn more over the next few years. Okay, next slide. Another thing to mention from the technical perspective, as more work starts to come through in this regard, is actually we now have the ability to use existing conventional refinery equipment to produce sustainable aviation fuel by co-processing. So we can feed up to 5% of the vegetable oils or waste oils into a refinery unit, and therefore produce jet fuel with up to 5% sustainable aviation fuel already incorporated. And that's now permitted under the main jet fuel specification. And that can have advantages in that there's not so much investment required to be able to produce that, and it can be a very cost-effective way of producing. So that could hopefully help unlock a bit more supply going forward. Okay, next slide. And this slide is really to make 2 points. I think one is that this is very much business as usual now. As alluded to at the start of my presentation, we've been active as AirBP for several years now. We've supplied it through the main hydrant system at a number of airports, and through the conventional refueling process where there isn't a hydrant at a number of other airports. We've actually supplied at 15 different locations in total across 5 countries in 3 continents. This is very well established now. All the protocols are in place, and I think we kind of need to think of ourselves as through the demonstration phase and we're really now into the commercial scale-up phase. You can see a lot of the airports here. I don't know how good your IATA code recall is. Most of these are in the Nordics. That's where we've had a lot of success so far, and we found that the Scandinavian consumer passenger is very environmentally conscious, and they are expecting their airlines to really respond there. That being said, we're seeing those kind of those trends really start to spread elsewhere. And in the UK, for example, the risks to the environment around private jet use have been front page news, with our Prince Harry really being called out by a number of tabloid newspapers for flying his family around by private jet, despite carbon offsetting, and therefore trying to do that in a responsible way. So this is becoming more of a mainstream issue, and certainly we're going to see that that public interest in how we're managing the emissions of our industry and trying to find more sustainable solutions becoming an increasingly important topic. As AirBP, we're working with a number of companies here. We've worked with several different suppliers. We have some key collaborations and partnerships here. So we have a collaboration agreement with Neste to develop supply chains for sustainable aviation fuel that we announced last year. That enabled us to deliver fuel to a number of customers in Europe this year. And as I mentioned, we invested in Vulcan Bioenergy, a waste to fuels company in the US a few years ago, and continue to develop that partnership. Okay, conscious of time, I'll just jump to the last slide, please. So I just want to kind of sum up where we are and what the challenges are to enable us to grow, the challenges we need to address in order for us to really grow this industry as quickly as we can. We've heard how important it is that we find solutions here, because we can't rely on electrification, unlike road transport can, to really get us a lot of renewable energy into the system. We need to decarbonize the fuel. To do that, we need more production of sustainable aviation fuel, and therefore we need to scale up that production so we can make it in a more cost-effective way. We need to be flexible around the feedstocks that we can use, all the time ensuring that the product is of the highest quality. We've got all the protocols in place to do that. Ensuring that the greenhouse gas reductions are certified and can be passed through, all the benefits of that are passed through to customers. To do this, we're going to need to really work together. We need all the parts of the value chain, all the parts of the industry to align around the need to respond here and around the solutions that we need to make that happen, as well as really being effective in the way we communicate the benefits of this to our stakeholders. To do this, we will need government support. We need long-term policy to enable these investments to be made. But with that in place, and with us all understanding the importance of this, then we're really confident that we've got all the pieces together here to make the industry scale up and deliver the solutions that we need. So thanks again very much for your attention, and to the team for the opportunity to share this with you today.
All right, thank you very much, Tom. And as you mentioned, our listeners today will receive both presentations in an email. Now we have time for some of the questions that have come in. If your question isn't asked, we'll pass them along to Marcelo and Tom and email you the response. So we'll start off with, has any study been done as to whether the emissions are in fact better for the environment? And that's a question, Tom, from Mark.
Great, yeah, thanks, Mark. So yeah, as I sort of alluded to, there's a number of studies that have been done, but I think there's still more work to do. So in terms of the way that the fuel burns itself directly, it's very slightly more efficient actually to burn sustainable aviation fuel than it is regular jet fuel. There's a maybe 1 to perhaps 2% improvement in a pure combustion efficiency perspective. But in addition, there are these other associated benefits from its higher purity, if you like, where with lower aromatics and less sulfur, creating sulfur dioxide, you can end up with a better outcome from an air quality perspective as well. There's a NASA study that is looking at the effects of that at high altitude, and a number of other things there. And there was a reference under one of my slides to a Canadian study as well.
Marcelo, Frank would like to know, does SAF require any special filters or changes in the testing dailies, monthlies, etc.?
No, I'm sorry. There is no change necessary. You can use your sustainable alternative fuel with the same performance that you use the conventional jet fuel. It's one of the critical points that we request that these alternative fuels must be dropped in. We cannot make any change in the aircraft or in the infrastructure that you have in, for example, in the tank farms at the airport. For the aircraft or for the storage of the sustainable alternative fuels, the requirements are the same. The performance will be the same. We need to. It's not necessary to change nothing in your aircraft fuel system or engine, something like that.
Okay, Tom. Matt would like to know, so how does a single FBO go about getting into SAF? My location has a broad mix of users. Don't I have to get them on board and my supplier? How do I close that gap?
Yeah, it's a great question, and it's a tricky one to solve right now. It's very location dependent because of the supply still being only quite limited. So as I said, there's only really two producers today. I expect that situation is going to change within the next 2-3 years. There'll be a number of extra producers coming onto the market now that there's quite a clear demand signal. So we'll see that improve. Really, it would be a question of working through your fuel supplier, and that is, I think, how the product's going to flow. It's going to be coming with the existing fuel supply in most cases, because you want to try and avoid adding any additional sort of logistics movements here to keep that as carbon efficient as possible, and as simple logistically as possible. So as I say, it may be tricky for the next sort of year or two as supply comes on, but it's the sort of thing that we should keep talking about and seeing about in specific cases if there is a solution that can be found.
Okay, Marcelo. Ed would like to know what type of long-term testing has been conducted on the engines of these aircraft. How many test hours?
It's not a specific amount of hours defined. It's defined by the engine OEM according to the characteristic of the fuel that you have, and they have a specific acceptance test procedure. Usually, you make these tests in a basis that you call back-to-back. You run conventional jet fuel and run the same test procedure with alternative jet fuel, and after that you run with conventional jet fuel to compare before and after the test with alternative jet fuel. But it's determined by the OEM, and it depends of the type of the engine and what of the performance that you want to check. But it's not a complex process. It's the same process that you have when you are qualifying with conventional jet fuel.
Okay. Tom, one of our listeners would like to know, what are the prospects for governments over the next 10 years to heavily tax jet fuel to incentivize sustainable fuel usage and suppress business aviation flying?
Wow, a lot of aspects in that question. It's a really good one. I think quite a topical one. So we're starting to see in Europe at least some increased interest, shall we say, from governments in increasing taxation around aviation. That will be done in different ways. That may be as sort of passenger duty, or it may be as a specific CO2 tax, as we've seen in Sweden. But certainly that's going to start to happen. I think there is perhaps an opportunity to try and, as an industry, come together and show what we are doing to try and address the emissions problem, to try and keep ahead of the curve here and not just be told what we're doing, but to be able to kind of keep our say in that as we move forward. But yes, I certainly do see more of those kind of initiatives coming, and that's something we need to be prepared for. I think the part of the flip side of that is that the more tax related responses are put in place. So the more governments use tax as a mechanism here, the more that prevents reinvestment into sustainable options here. I mean, an incentive to create new sources of sustainable fuels that may be supported by the state, but can create a local industry, would certainly seem to be a pragmatic way to try and create solutions and ensure that the right options come into the market. However, as I say, I think it is quite likely that that tax is going to be a part of the suite of options that governments choose to use here.
Marcelo, one question which I'm sure our listeners are interested in. Why is SAF still more expensive than conventional aviation fuel? And how fast will we get that learning curve down that sustainable fuel is the same price as traditional fuel?
Well, it's difficult to say when, but the main reason, as was mentioned by Tom in the end of his presentation, the main reason is the scale of production. Today, we have around 11 plants or refineries producing or under construction to produce sustainable alternative fuels for aviation. On the other hand, we have hundreds of crude oil-based refineries. But it's important to say that we are delivering a different product. We are delivering a product with more added value, as was mentioned in the Tom's presentation. We have an SOx reduction. We have a reduction of particulate matters in terms of the final product. And I believe that the SAF will be competitive, not in the short term, but I believe in the mid-term will be have a competitive product. One point here, and it was already highlighted in this discussion today, is the public policies supporting the development of the chain, supporting the development of sustainable feedstocks and make this chain able. When we improve the feedstocks and the technology, we can reduce the final cost and seeking price parity in terms when we compare with the conventional jet fuel.
Tom, Matt would like to know, once SAF is sourced and added to the fuel supply, are there any liability issues different from conventional fuels, or do fuel suppliers have the same liability as with conventional fuel?
No, there's no change in that regard. Again, because it's covered under those existing, the same specifications as all fuel is supplied under. There's no difference in any treatment around that, whether that's from a physical or from a liability perspective.
Marcelo, there's a lot of buzz right now on electric and hybrid aircraft and their environmental benefits. Would improving investment in the aircraft electrification instead of SAF fuels be the solution?
I think that will be the solution, but not for now. Electrification propulsion research is growing fast, but not fast enough to replace liquid fuels in aviation. From short to mid-term, I believe that maybe aircraft or smaller planes can have electric propulsion, but aviation requires a high energy density batteries and compact as possible. I believe that it's a solution, but not for now. It's difficult to say the year that you have, for example, long haul flights, fully electric or hybrid electric. We have 24,000 aircraft flying, and we need liquid fuels. There is no chances for replace this aircraft with batteries. We need this liquid fuel now, and electrification will be part of the solution, but not for short term.
Okay. Tom, Harm sent in a question saying there's 6 billion liters in purchase agreements for SAF currently. How does that compare to conventional fuel in percentage? I guess he wants to know what is the percentage that would make up of the aviation fuel pool currently.
Yeah, so I mean that 6 billion liters I think has a time function to it as well. So that's not all per year. I think that's actually over the life of those agreements. So within the context of close to 100 billion gallons of aviation fuel demand, there's there's not really, well, I'd say there's still a long way to go before we're getting towards material percentages of that, even with what sounds like quite a large commitment in terms of purchasing. Those kind of commitments are really helpful. However, that does give the demand signal, that does encourage potential producers to go out and develop and build the production facilities and feedstock technology and production to continue to develop. So those are great signals to send. It is a big challenge for the industry to get to the kind of levels that we were talking about. So I was talking about 150 million tons a year of production may be required by 2050 for us to be on target here.
Okay, we have time for just one more question. Marcelo, Mike would like to know, if burning the fuel, do you get the same CO2 emitted as standard Jet A?
Technically, yes. When you are burning in terms of the CO2, yes. But when you look this life cycle, for example, when you check SAFs, for example, the case of SAP or the HEFA technology, they can reduce something like between 60 to 80% in terms of CO2 emission in the full life cycle of the process. This is the point. When you burn the SAF, the performance is the same. But when you analyze that the CO2 emitted will be absorbed by crops or plants, and will be processed to grow another crops, you have the savings in terms of the CO2. But in the aircraft, the performance is the same in terms of emission.
Well, thank you for that. We have just about run out of time for today, so that will conclude our webinar. Once again, we'd like to thank our panelists, Marcelo Gonçalves and Tom Parson, and our webinar sponsor, World Fuel Services. If you'd like to delve deeper into this subject, we'll be holding a free luncheon panel next month at NBAA's annual convention in Las Vegas, and the registration information is now on the screen. For Aviation International News, I'm Kurt Epstein. Thank you for attending.